Okay, so we have to find the resistor equivalent between terminal A and B, and then after we find that, we have to use it to find I. So first thing, this circuit is a little tedious to work with, as there is no clear way to, do series or parallel. So we're going to do the delta triangle to Y method. So let's start by focusing on this. So this portion of the circuit, we can actually rearrange it into like a triangle, because notice this is one node, so that means these two are allowed to connect to each other. We can rewrite it like this, okay? So this is the 5 ohm, this is the 10 ohm, and this is the 12.5 ohm. So now what are we going to do from here? We're going to turn this triangle and turn it into a Y looking circuit, which will make this easier to solve. So the Y looking circuit in a different color will look something like this. Okay, but it'll have different value numbers. So how do we find those numbers? Well, there's a formula to figure this out. First, let me draw the new circuit here. Okay, let's call this one X, let's call this one Y, let's call this one Z. So how do we find X, Y, and Z? So we'll start from here. So there's going to be a number on the top, number on the bottom. So the bottom numbers are pretty much all three of these added up. So it'll be 12.5 plus 10 plus 5. Now the top part is where it gets tricky. So the first thing we're going to do is we're going to look down here. Look at the X and look at this portion. If we draw a dotted line straight down, aligned with the X, we notice we'll hit this 5 ohm resistor. So that means we won't include that 5 ohm resistor in the numerator. Now that means we can only include these two. So it'll be 12.5 times 10. Okay? And what is that equal to? 12.5 times 10, that's 125, divided by 12.5 plus 10 plus 5, and that's 4.545. Okay, so that's what this portion is equal to, 4.545. Now let's look for Z. Okay, so to find Z, let me erase all of this. Okay, to find Z, let's draw a dotted line directly aligned to it, and we notice that this dotted line would be hitting this portion, because if we were to put this inside this triangle, this portion of the dotted line would be hitting the 12.5 ohm resistor, so we won't include that. So Z will be equal to 10 times 5 all over 12.5 plus 10 plus 5. So 10 times 5 all over 12.5 plus 10 plus 5, and that equals 1.818. So that's what Z is equal to. Now for Y, again, dotted line aligned to the Y resistor, and we see if this circuit was actually inside the circle, it would be hitting the 10 ohm resistor, so that means we don't include it. So Y will be 12.5 times 5 all over 12.5 plus 5 plus 10. So 12.5 times 5 all over 12.5 plus 5 plus 10. And that gives us 2.273. So Y is equal to 2.273 ohms. Now we can redraw the circuit. Hold on, let me bring it a bit more down. Okay, so we turned this circuit into something that looks like this, and these two circuits are still the same, and it's much more easier to solve now. So notice we can add these two and these two up. So 1.818 plus 20, that gives us 21.818. And we can add these two up. So it'll be 15 plus 2.273, which is 17.273. And notice these two are in parallel. So it'll be 1 over R equals 1 over 17.273 plus 1 over 21.818. So let's see what R will be. Okay, so R will be equal to 9.64. So that means this whole portion, this whole portion will be 9.64. Now we can add these two up. And we have 14.18. Now we just have these two left. So these two are in parallel. So it'll be 1 over 30 plus 1 over 14.18 equals 1 over R. Solve for R. So that means R will be equal to 9.628. So this whole circuit, its resistor equivalent is 9.628 ohms. And then let's include that voltage source. Now we can find this current. We know that V is equal to IR, voltage is 120, and resistor is 9.628. So I will be equal to 12.5 amps.